In this lesson, we are going to create our first React 3 Fiber application. Yes, we are going back to Three.js after this long React lesson. So we already know Three.js. We now know React, or at least the basics of React, enough to do the following lessons. It's time to learn how to integrate Three.js into React. And the best solution to do so is by using React 3 Fiber. React 3 Fiber, or just R3F, is a React renderer. The idea of a renderer, in general, there are many renderers for React, is that you write JSX code and it gets rendered into something else. And in this case, it gets rendered into Three.js. So you write, I don't know, some tag-based things like a mesh, a geometry, and then on screen, you will get a mesh and the geometry appearing in the Three.js scene. Sounds great. And it is. Here's a very simple example. To create a mesh composed of a box geometry, so you know that from Three.js, and a mesh basic material, you create that mesh using JSX, so it looks like HTML. You create a box geometry inside and you auto-close it with the slash, you know that, and then you create a mesh basic material and you get a mesh on screen, and we are going to get that. You will see it's almost that simple. We just need to set one or two lines of code around it, import one or two dependencies, and we are good to go. So React 3 Fiber will set default parameters to simplify our life. As you will see, in just a few lines of code, we get our scene running. If you remember from the first lessons of Three.js, we had to write maybe like 20 lines of code before getting something. In this case, while using React 3 Fiber, in just like 3 lines of code, 4 lines of code, you get your scene, and it's working and it looks good, you will see. So about the setup, for the starter, without an S, we have a very simple React project. As you can see, we can check it quickly. It's very similar to what we had in the previous lesson. So it's from scratch. We have some dependencies, React, React DOM, React scripts. Currently nothing about Three.js. In the application, so in the src folder, we have the index.js file with only soon to be a badass React 3 Fiber application. It's just a text that you can see here and some style. Actually, no, the style is empty. We're going to put a few lines of code in the style, you will see later. And I already started the project. To start the project, it works like the previous lessons. You do npm install. Okay, so from the DevTools, you do npm install. I'm not going to do it because I already did it a few minutes ago. It installs the dependencies, so the 3 dependencies we added to the project: React, React Script, React DOM, and then npm run dev. It's the usual commands to start a project, and when you do that, you get this result. By the way, you might have a little console in here telling you that you better install some dev tools, React dev tools. You can ignore it for now. I mean, if you want to check it, just check it. I think there is a link with it. So in your console, when you run the project, you should have this little message here. If you don't have it, ignore what I'm saying. We're going to see that later. I think it's in the next lesson. It's some tools to debug React. We are going to see that later. So for now, you can just ignore it. All right, I'm going to hide this and hide this. We're going to need it a little later anyway. All right, great. React 3 Fiber setup. It's time to create our React 3 Fiber application because we have nothing about Three.js nor React 3 Fiber for now in this project. Adding React 3 Fiber is quite easy. Yes, good news. I know the lesson might be a bit long, but we are going to see a lot of features, but just setting up React 3 Fiber is super easy. First, we need to add 2 dependencies. So it's going to be this one. So at React 3 Fiber. As you can see, there are some dashes, some slashes. We're going to talk about that. And the classic Three.js dependency. So let's go. I'm going to open the terminal again. You can use whatever terminal you want. It's the usual thing. So npm install. And I'm going to install 3 first, 0.145. And we are forcing the versions. And we do the same for React 3/Fiber. It's going to be the 8.8. All right. We force the versions, as I mentioned, I think 1 or 2 lessons ago, to prevent surprises, to prevent like break changes with the various libraries that we are going to use through this whole chapter. So use the same versions as me if possible. If you want to try with the most modern versions of the libraries, you can, but be careful, there might be some differences. And if you need help about those changes, you can ask on the 3GS Journey Discord server, or if it's related to React through Fiber, you can ask on the Poemanders Discord server, and yeah, we will try to figure out how to optimize it, to fix it. Okay, so I press enter. It's going to install both dependencies. Should be quite fast. Yeah, as you can see, quite fast. I have vulnerabilities. You can ignore vulnerabilities. Okay, it's fine. We are in local. Usually those are totally harmless, so you're fine. Don't worry. For real projects, you can update the dependencies to the latest version, but you will have to fix probably some stuff. All right, enough talking about the versions. Yes, about that. So I'm going to start the server again, npm run dev. We should not have any difference. Yeah, okay, because we are not using those new dependencies yet. About the way we install React through Fiber, as you can see, we wrote at React-3, and then followed by /fiber, and then the version. This is very interesting. The beginning, we have a at. This means that it's part of a bigger system. The system is named React 3. We call that a scope. This means that there are multiple parts in that scope. And the first part we are adding is just fiber. Okay? Later, we are going to install more parts of that React 3 scope. You will see. No spoiler. It's going to be super cool. You will see. And yeah, there are other parts and we are going to use them. Yeah, by the way, I always say React 3 Fiber, but when you talk about the general thing of having React in 3GS in React using that solution, it should just be like React 3. And if you want to talk about just that library, it should be just Fiber. But I'm going to say React 3 Fiber. It's okay. So let's go. We are going to talk about the syntax. It's not going to work yet. You can actually just relax and check my screen. I'm going to explain a few stuff, and then a little later we are going to implement that in your code. Don't worry, it's coming. So yeah, don't worry if you don't understand. We are going to go through some examples, and then we are going to practice a lot through this whole chapter. Just for now, you can just chill and watch my screen. How do we create a simple mesh? And we already saw that a few slides ago. In native 3GS, it looks like this. Okay, if you want to create a mesh, so I'm just going to show you on my screen so that you have the example here. You create, it's the usual thing we have been doing for so many lessons. You create that mesh, you associate a box geometry to that geometry property, you associate a mesh basic material or another material to that material of the mesh, and then you add it at the end. You can also do the different way, you know, when you create a geometry, you create a material, and then you create the mesh out of both those. So it looks a bit like that. Okay, like this. And then you send it like that and like that. It's the same, okay? It's the same. I just want to separate a bit so that it's more representative to how React through Fiber will do it. So yeah, it looks like this. So this is native JavaScript. It's just fine. Native 3GS. It's okay. We have been doing that for a long time. Now check how we do it in React through Fiber. It looks like that. So the code is not going to work yet. Don't do it. Soon, later it's going to work, don't worry, but for now it's not working. If I do that, I'm gonna get an error. See, 3 is not defined. Oh yeah, by the way, now it's because of that. We can remove that. See, it's not working. So in React through Fiber, it looks like that. So we are using GSX. As you can see, I put it inside the render. So this is GSX. We create a mesh. The indentation in GSX is not important, but at least we understand that the box geometry is inside the mesh and the mesh basic material is inside the mesh. And just by doing that, you get your mesh, and it's exactly the same mesh. That's great. It's a bit more simple, and everything will be much more simple, you will see. So yeah, a few words. The geometry and the material are automatically associated with the mesh because they are inside that mesh. that mesh tag. The syntax is shorter and easier to understand. Just by watching it, you understand that it's box geometry and mesh basic material inside a mesh. This one needs a little more effort to understand it. It's okay, but it's a bit longer to understand. Default parameters are automatically set for us. By that, I mean that we didn't have to provide the 1, 1, 1 here. And this code will just work. We will see the box and the default parameter will be 1, 1, 1. So we get the same result. So it's faster to write. If you just want a box and you don't care about the size, it's going to be 1, 1, 1. And at least you have something on screen with minimal code. All right, let's see another example. How to change the position and the rotation. So in native 3GS, it looks like this. We create a mesh, we change the position. I use the set so that it's faster to write. And I put 1, 2, 3. So 1 on X, 2 on Y, and 3 on the Z. And then I play with the rotation and I create the geometry and the material and add it to the scene. All right, no big deal, cool. What do we get in React 3 Fiber? When in React 3 Fiber, it looks like this. We set the position like this. And we send an array. Okay, we will see that a bit more in detail. But we can also target specific axes like this. So the rotation X, we set 0.5, and we get the exact same result by just adding 2 attributes. All right, sounds cool. Nested object in 3GS, if you want in native 3GS, if you want to put, I don't know, like 2 meshes inside one group, okay, it looks like that. This is where it starts to get a bit annoying because we have some mention of a group, then the meshes, then we add the meshes to the group. The group has been added to the mesh. It's okay. We get used to that writing, but it's getting quite big. In native, in 3G, React 3 Fiber, we get something like that. So obviously it's a bit longer because we have to create multiple meshes too. I'm going to put it there. Multiple meshes and a group. But as you can see, the hierarchy, the structure of the tags makes sense. We have a mesh and another mesh inside the group, and both will be added to that group without doing anything. Sounds good. Sounds super easy. And just by watching quickly, if you have a good indentation, which I hope you always do, you can see the structure just by watching quickly. You know that it's a group and there is 2 mesh inside. And if you want some details, you can see that it's a box geometry and a sphere geometry, and they both have a mesh basic material with different color. It's super easy to understand and to write. So how does React 3 Fiber know how to combine components? Maybe it just makes sense. Like, okay, there is a mesh inside the group. It makes sense. The mesh will be added to the group. Okay, there is a box geometry inside the mesh. Then the box geometry should be added to the mesh. It's not that simple. There are some kind of rules. JSX being a tag-based language, yeah, we end up with things inside other things. And we are going to use the previous example. Let me see. Yes, that's exactly the same example. So we can use this one. So we have 2 mesh inside the group. React 3 Fiber will create the group, then call add on it and pass it to meshes. So it's kind of automatic. If there is a mesh inside a group, everything that is inside something, the add method will be called. All right. So we have the mesh and the add will be called to add those meshes to the group. It's kind of automatic. But what about the box geometry and the sphere geometry? Sorry, the box geometry, the sphere geometry, and the mesh basic material. We don't want to call mesh basic material and sphere geometry. We don't want to call add on mesh. We don't want to do mesh, add, sphere geometry, mesh, add, mesh basic material. This is not the way of adding a geometry and a material to a mesh. So how does React 3 Fiber handle that? To understand it, we need to talk about the attach attribute. The attach attribute allows the developer to assign component to a specific property of the parent instead of trying to add it. What does it mean? If we want to write this code by using that attach attribute I'm talking about, we should have write something like this. Let me show you. So it's attach material. And for this one, it's going to be attach geometry. When you write this, so you can ignore this one for now. When you write this geometry won't be added to the mesh. This geometry will be assigned to the geometry property of that mesh. Let me repeat. There is an attach attribute, meaning that this box geometry, so React through Fiber will create a box geometry, and instead of adding it to the mesh or to the group or whatever, it's going to assign that box geometry to the geometry, because we wrote geometry here, property of the mesh, okay? To the geometry property, so this one, of the mesh. Oh, by the way, I wrote 1, this one should be 2. I did a mistake. So yeah, the box geometry will be assigned to the geometry of the mesh. And this is how React through Fiber knows how to attach things to other things. So we should have the same one here and the same one here. Okay, that's the idea. Initially, we had to write the code like this. But, yeah. We didn't have to write those attach attributes. And it's because React through Fiber will first check the name of the component. Okay, we didn't have to say this box geometry must be assigned to the geometry property. We didn't have to do that because, check that. I'm gonna get it. Yes, and this one. Yeah, like this. Because React through Fiber will check that name here. The name. This is written box geometry. When it ends with geometry, React through Fiber will just consider that it's attached geometry without us having to write that. And it's automatic. In other words, I'm trying to explain things a bit in detail, but you don't really care. It's automatic. If something ends by geometry, it will be attached to the geometry of the mesh. If something ends with material, it will be attached to the material of the mesh. Otherwise, it's going to add it. It's going like the mesh. It's just mesh. Well, React through Fiber will add the mesh. So it will call add on the group to add the mesh to the group automatically. And you have nothing to do. It just works. The question is, which Three.js classes are supported by React through Fiber? As you can see, we have group, okay, mesh, box geometry, mesh basic material. And we wrote them like this, okay, it's tags, in camel case, okay. Those components match the Three.js classes. So as you can see, mesh will create a 3 mesh, box geometry will create a box geometry, a 3.box geometry. But which Three.js classes are supported exactly? Is there like a list somewhere and I have to update that list? React through Fiber will implement all classes automatically. This is done like totally automatic. If Three.js updates and we have new classes, new features, new materials with cool effect and stuff, React through Fiber will support it immediately. There is nothing to do because React through Fiber will kind of pass all the classes of Three.js and support them. And it's really automatic, like box geometry. It's not written in the React through Fiber. Okay, the box geometry should create, the tag box geometry should create a Three.js box geometry using that specific class. It's done automatically. So you don't care, you don't have to worry for Three.js updates. This will just work without doing anything. And that's super cool. By the way, why camel case? Can't we just write mesh with the uppercase M instead of mesh? Well, this is a React convention. It could have been done differently, but in React, a native host element, the one available in the renderer, so I'm talking about the Three.js, the React through Fiber renderer, or in camel case. It's kind of a way to differentiate them. Custom components, the one we create, the one we will get from React through Fiber Dre, I'm kind of spoiling what's coming in the next lessons, will be in Pascal case, sorry. In the case of React through Fiber, you can just think of it like automatically generated primitive components or in camel case. So mesh has been automatically generated, box geometry the same, mesh basic material the same, the group the same, those are automatically generated. They are in camel case. More specific components, the components we create or the components we are going to take from Dre, you will see later, are going to be in Pascal case. Nice. A lot of talking, a lot of examples. It's time to write some code. It's time to make this work. We're going to create our first React Free Fiber scene. It's going to go super fast, you will see. So first, we need what we call a canvas. I'm not exactly talking about the canvas we used to have, you know, in the HTML, the canvas tag. I'm talking about the React Free Fiber canvas. And we need to import it. So I'm going to go back a little on that example. So normally you should not have write this. You can get rid of it if you wrote it. We can get rid of the text and we can get rid of that example. All right. I can put like a test. As you can see, it's working. There is no error in there. First, we need to import that canvas component from @react3/fiber. It's a bit longer to write, I know, but as you can see when I start writing it, so React 3, and now we have fiber, okay, because it automatically know that there is a fiber part in that scope. Also, sometimes it doesn't always work, unfortunately. It depends on your VS Code configuration and stuff. If I write just canvas, let's see. Oh, it's working. Sometimes it's working, great. It's really rare that it's working when recording, but that's a good thing. As you can see, VS Code found the canvas components of the canvas, let's say, class from React 3 Fiber, and I can just press enter and it imports it automatically. All right, so be careful with that. And we are going to open it and close it separately. Okay, we have the opening tag and the closing tag. We save, nothing on screen. Wait a moment. If you check the DOM, you will see that the canvas has been created. Let's see, you don't have to do it, you can just watch my screen. Yes, there is a canvas right here. So the size is a bit weird. As you can see, when I hover the canvas in the elements tab of my debug, we can see the blue thing right here. And there is a canvas. That's great, but the canvas size is not right. It's very easy to fix. We are going to do it right after. But first, we want to see something on screen. And I told you it's going to be quite simple. I'm not going to copy and paste it. I'm going to write it with you. We want to start with, we want a mesh at the center of the scene. So I'm going to create a mesh. Be careful, it's camel case. So in the case here, it's a lowercase. And now I want, let's do a more complex geometry than just a sphere or box. I'm going to create a torus knot geometry. So torus knot geometry like this. And I'm going to use a mesh, normal material like this. Let's see. And I have it. And it's working. You might say, yeah, it's working. Why not? We have a mesh, a torus, a mesh normal material, but we have set almost nothing. Remember what we have to write in a native JavaScript to get that torus? We have to write quite a lot of things. And I'm going to list you all the life improvements we have right now a bit later in a few slides. All right, let's talk about the resizing first, because that torus looks a bit small, but it's because the canvas, as you can see, is small too. It only takes this space in the screen. So the canvas created by React 3 Fiber, I'm talking about the DOM element canvas. Okay, there is the canvas component, but there is a DOM element canvas. The canvas component create that DOM element canvas. Created by React 3 Fiber, we take the size of its parent. So in our case, the parent is the root. And there is a bunch of div, but they all have the size of the root. Okay, so that canvas will automatically resize according to the parent, which is the root div. We have right here, it's the root div we created in the HTML right here. You don't have to open it. We are not going to change this one. But since our application is created inside that root div, the canvas take the size of the root div. And it also add some divs, but we don't really care about those, don't worry. So what we are going to do is that we are going to make the root fill the viewport and do the same with the HTML and the body so that everything just fits the viewport. We're going to make kind of a full viewport 3GS experiences. And to do that, we're going to go inside the CSS. We don't have a lot of CSS in this chapter, just some lines here and there. So you can just do that. I'm going to do it with you. HTML, body, root. So we target the HTML, which is at the top, the body, and the root. And we are going to write position fixed. Top 0, left 0, width 100%, 8 100%, and we are going to add overflow hidden so that we can't scroll. And it's working. Easy. I didn't have to reload. That's great. Cool. Let's move forward. And let's talk about what just happened, because there is a lot of things that just happen without us having to do anything. First, we didn't have to create a scene. Check the code. I go back to the index.js. We created that canvas component from React 3 Fiber, and we added a mesh inside of it. And without doing anything, it seems that we have a scene. Okay, great. We didn't have to create the WebGL renderer either. Remember, when we have to create that WebGL renderer, we have some options to pass to it. We can set the canvas and stuff. Nothing to do here. It's done automatically. The scene is being rendered on each frame. I know you can't see it and we can't yet interact with it, but the scene currently is rendering regardless of your frame rate. Okay, that's cool. The default settings are making it look appealing. If you check your screen, you might see that it seems that there is an anti-alias because you can't see the stairs. If you are using a device with different pixel ratio, it will look good too. And there is also some encoding and a lot more things happening, but we are going to see those later in this lesson. We didn't have to place a perspective camera, and that's cool. The camera, if you remember, we have to create that camera. We have to provide a bunch of parameters, you know, the field of view, the aspect ratio, the near, the far, etc., etc. We didn't do anything here. It is a perspective camera by default. We can change that. We are going to see it later. And it's just working. And the camera is not at the center of the scene. This is a classic mistakes that beginners do with Three.js. They add a camera, they add an object, and there is nothing on screen, and they panic and they ask, I can't see my object. Well, it's because the camera is at the center of the scene and you are inside your object. This is a classic mistake. By default, in React 3 Fiber, the camera is a little backward. And we didn't have to do it ourselves. When you resize the viewport, everything that needs resizing is handled automatically. Check that. I'm going to resize the viewport. Looks good. Looks good. The viewport is being resized. The canvas is being resized. The renderer is being resized. The camera is being resized. The aspect of the camera is being resized. And if we have more things that need resizing, they are being resized automatically. We have nothing to do. We didn't have to provide any specific value to the torus node geometry. I told you earlier there are some default parameters that will just make things look okay. And in our case, it looks good. We didn't have to import the mesh, nor the sphere geometry, nor the mesh normal material. We don't have to import stuff. We just write code. It's called declarative, and it's just working. I'm going to talk a bit more about that later. We don't have to reload the page most of the time. I told you, I think, about that in the previous lesson. It's thanks to the hot module replacement, also called hot module reloading. You just change stuff. See that? I'm going to remove that. It's gone. I put it back. It's here. I didn't hit the reload shortcut. I didn't have to click on the reload button. It just works. If something looks odd, you think there is a bug, give it a little reload. All right, sometimes it doesn't work. It's not necessarily the React 3 Fiber fault. Sometimes it's more the developer fault, like you don't destroy events or things like that. We will see some examples later. But if you think there is something going wrong, just give it a little reload. All right, let's do some refactoring before having some fun with those new features we have. First of all, as you can see, we have a fragment here, but we only have one element here, so one component here. We can get rid of the fragment. So you can remove the fragment like this. You get the same result. All right, cool. Next, try to keep your code as simple as possible, as always. Later, we're going to use hooks. So remember from the hooks in the previous lesson in the React, we had the use state, use effect, use memo. I think there was a fourth one. Yeah, I forgot anyway. So those hooks, okay, they are just fine. But in React 3 Fiber, we will have access to React 3 Fiber hooks. Those are very specific to React 3 Fiber. And they can only work in components created inside the canvas. Meaning that we can't use hooks right here, like there. I can't use a React 3 Fiber hook here. most of them. Actually, there are some hooks that we can use outside, but we can't use it here. So we need to create a component that will just kind of hold the whole React through Fiber application we're going to create. All right, don't put your whole code in here. We need to create kind of a big parent component so that we can use hooks inside that component. You will see a bit later, we're going to use those hooks. So what we are going to do is that we are going to create a component. You can try to do it. You should know how to create components because this is just React. So we create a new file, experience.js. Sometimes we call them app, application, WebGL, whatever. I like to call it experience because that's the WebGL experience. So I call it experience. We export a default function experience. This is just like a React component because yes, we can use default React component in using React through Fiber, using the React through Fiber renderer. And we return, and I'm going to put what we had in the index.js. So this code here, I'm going to put it in here, but I'm going to add a fragment around it so that we can add more stuff in it. All right, so that we can add more meshes without having to change the structure. So that's why I'm using that fragment. Check that you have the same thing as me. We are exporting default function experience, so it's going to be a component. We are returning a fragment with the same mesh that I took from here. All right, let's go. Now we go back to the index.js. I can close the sidebar. Actually, I'm going to keep it so that you make sure that you have the same files as me. And in here, I'm going to add the experience. I can try to rely on the auto import. So experience. See, I didn't imported the experience. I just wrote experience. So I opened the tag experience and VS Code found it for me. And I can just press enter and see it imported it. I'm going to change a few things. First, I'm going to close it. Auto close it like this. And secondly, I'm going to add the JS. You know that I don't like to have this empty extension. I know it's working. See that? I'm removing it. Everything is working. I add it. Everything is working. And if you prefer to use JSX for component, just use JSX for component. I like the JSX things, but it gets a bit messy. So I prefer to use just JS and I'm fine with it. All right. I repeat why we did that. Now in the experience.js file, more precisely in the experience component, right here, we can use React through Fiber hooks. We are going to discover those hooks together. There is a few of those hooks that I need to show you, but now we can use them here. We would not have been able to use it there, but we can use them here because it's a component. So experience is a component inside the canvas. That's what matters. The experience is inside the canvas. All right, let's go. So creating and handling meshes. Let's see some details about the meshes and how to set meshes. We created our first mesh with a tag. Okay, great. And we didn't have to import those tags. This is the declarative coding. All right, it's cool. We don't have to import everything that we want to use. React through Fiber, we automatically know that we are creating a mesh, not a geometry, and a mesh normal material. This is the declarative coding. React through Fiber, we create the corresponding instance automatically, blah, blah, blah. That's what I just said. In experience.js, replace the geometry and the material by a sphere geometry and a mesh basic material, just to practice a little. So we have a sphere geometry, and we can put a mesh basic material, just like that. We save and we get this. All right, cool. So it's working. Great. You can see that we have a default geometry. We can see something. There is a sphere here, although it looks more like a circle. It's a sphere. And the mesh basic material is not empty by default. We have some kind of gray. Okay. We're going to be able to tweak that right now. So now if you want to change the sphere geometry, you can still rely on the Three.js documentation. And as you can see on the Three.js documentation, there is the usual parameters for a sphere geometry that you can see here. And the first parameter are the radius. The second parameter is the width. segment, and the third parameter is the height. There is more parameters, but we just want to create a sphere. Those are to create like a half a sphere or portion of a sphere. So we just want to play with the first three parameters. So how do we specify those parameters? To specify those constructor parameter, because those are used when the geometry is being created, you have to specify them in the args attribute. So you specify that args attribute, and we need to send an array to the args. This is very important because we use it a lot for all geometries. It's for some materials, for some other classes. So it will always be the args. Okay, the one you put in here when constructing the sphere geometry, it's set in the args attributes. Since we need to send an array, we're going to inject some JavaScript and send an array. All right, it's written like this. And then we have to provide the parameters in the right order. So in our case, it was radius, width segments, and height segments. So let's go. The radius, we can make it a bit better. So 1.5. For the width, we can put, I don't know, the width segments 32 and the height segments 32. I save, and I have a new sphere, which is a little bigger because initially it was 1, and now it's 1.5. All right, nice, easy. We just set the args and put the parameters in the order. And yes, as I told you, we can still use the 3GS documentation. In the case of a geometry, be careful not to update those values too much or animate them. And this is the same reason as in native JavaScript. When you change a geometry, remember when we did it for the galaxy? We generated the galaxy, and when we change, we tweak the that GUI or lil GUI, we tweak it and we destroy the geometry and recreate one. If you change those parameters, I don't know, like the user clicks on a button and this value increments or this value increments, the geometry, it will work, but the geometry will be destroyed and recreated, and destroyed and recreated. So it's bad for performances. For the same reason that we had in native JavaScript, we had to destroy the geometry when we want to change those parameters, okay? If you want to make the sphere look bigger, you have to change the scale on the mesh. All right. For the mesh basic material, it's a bit different because if you remember from the class, so the mesh basic material class, what you need to provide to the mesh basic material constructor is one parameter, and it's an object with all the settings that you want to set, like the color, wireframe, or whatever, some maps, some texture, etc. So if we want to do it right now using the same technique as for the geometry, we have to provide an args. So inject some JavaScript, okay. We still need to send an array, and in that array there will be only one parameter, one item, and it's going to be an object. So you get a curly bracket, array, object, and it gets a bit messy. But it's going to work. Like if I say color, if I write color red, I'm going to close the sidebar to have some room. Check that. I get the red sphere. And I can set, I don't know, like wireframe, true. And it's working too. All right, cool. But this is a bit messy. You can do it. There is no problem with that. If you prefer to do that, you can totally do it. But once you have a bunch of parameters here, it gets a bit messy. Thing is, you can also use attributes corresponding to the properties. Like here we set the color and the wireframe. Let's get rid of that arg. So be careful, it's starting here and it's ending here. So we get rid of the args. We get back to the bad looking sphere. Let me show you. I had to reload. Yeah, that's one of the cases where sometimes you have to reload. If I want to set the color, instead of setting it using the args, I can just set color and provide, I don't know, like medium purple. This one looks good, and I get my medium purple. Nice. And if I want to set the wireframe, so wireframe should be true. You don't have to write true. Just by adding the attributes, React Through Fiber, we consider that it means it's true, and we get the wireframe on the material, and it's working. And let me check. Yeah, you can still put false at it. Like if you want to specify it, I don't know, because it's control using a state or whatever, you can do wireframe false like that, and we get back to false, which is the same as not having the attribute, but sometimes you need more control on it because it depends on a state or whatever. We can keep the wireframe. Yeah, let's keep the wireframe. Make sure you have the same result as me. Like we change the color or wireframe on the material, we can play with the position, rotation, and scale on the mesh. And we've seen some example about that earlier, how to move the mesh around. We can change the scale. So it's not on the geometry, it's not on the material, it's on the mesh directly. We can do scale. And since the scale is X, Y, and Z, we have to provide, well, we have to inject something and then provide an array and provide the X, Y, and Z. So I put 3, 2, 1. And if I save, I get this. It's ugly, but that's just an example. Doing that, when you provide like an array like this, it will call set on the scale. All right. This is one way of doing it in native JavaScript. You have your mesh, you have the scale attribute, which is a vector of 3. And a vector of 3 has a set method. And when you call set method, you provide the X, Y, and Z. And those are automatically set on the X, Y, and Z properties of the vector of 3. So this is handled automatically here. You just provide an array and it's working. That's cool. By the way, if you're a bit lazy, I don't know if you have 1.5, 1.5, and 1.5. which happen a lot when you just want to scale your object, your mesh or whatever. When you have this case, well, you can just provide one value. And as you can see, I got rid of the array. I just put 1.5. I saved and it's still working perfectly. All right, nice. Some shortcuts, I love it. Your code will be so small, you will see. You can create full scenes and interactive scenes with just a few lines of code. So we played with the scale. We can obviously play with the position. So I'm going to keep the scale here and I'm going to add the position. By the way, the order of the attributes is not relevant. You can invert them. It's going to work just the same. And it's exactly the same. We provide like 2, 0, 0 in an array in the position attribute. So make sure you have the same as me. And it moves on the right because it moves on the X. And X is positive by default on the right because the camera moves a little backward. If the camera were on the other side, well, obviously it would move on the left. Maybe I said left. So right now it's moving on the right. If the camera is the other way, it's going to move on the left. You get the idea. We can target specific, like in this case, we have 2 and 0, 0. We don't care about the X and Z. We can target specific axes by doing position X and provide just a value like this. You can do that, a shortcut. Again, I love it. So I save and I get the exact same result. And if I put 1, well, it's moving back and I don't have to reload. Nice. By the way, what happens if we do this? I'm going to test, I'm going to put 3. It's working, but be very careful with that. It's working because we got lucky. All right, at some point the value is probably converted to a number by some process in Three.js or in React 3 Fiber, but it won't always work. If you want to provide a number, you should make sure to provide a number. Those are strings. If you don't specify the curly bracket to inject something, this is a string and this might bug. And I've seen some bugs. It's not with the position or the scale. It was more specific attributes. And I had to provide those using numbers only. So my recommendation is to always use numbers to specify units like this. And we can do the same with the rotations. I'm going to add, or it's not going to be relevant. It's a sphere. We can't see much rotation on a sphere. Well, the wireframe is going to turn a little. And we can target specific axes like rotation Y equal, and then I inject a value. It's going to be, we can use math pi. Why not? This is JavaScript. We can put whatever we want, multiply by 0.25. And it's probably turned, but I can't see much of it. Yeah, you can see it move slightly. You want to change it to a box? No problem. Box, geometry. I can set the default parameters just like that. And see, my box is rotating. Yeah, I think at some point we were supposed to use a box, but I totally forgot to put that in the slides. Anyway, that's my fault. All right, time to practice a little. So yeah, actually this was supposed to be a box. Who cares? We played with a sphere. It's kind of the same. So change it to a box. We can set the scale to 1.5, like that. And you can do a small exercise if you want to practice on your own a little. Nothing too hard, but still it's good to practice. Don't worry if you can't get it on the first try. It's normal. This is probably new for you. Create an orange sphere on the left. So I want you to create an orange sphere on the left. Put the purple cube on the right and remove the wireframe, and create a floor. So it's going to be just a plane below, and you might have to rotate it. All right, try to do it if you want. We're going to do it now together. All right, so what do we have? We're going to put the sphere. Yeah, let's create the sphere. So it's going to be mesh. So it's a mesh. A sphere is just a mesh. Then we create the sphere geometry. Sphere geometry. Yeah, by the way, sphere geometry, sphere buffer geometry, it's the same since quite many months. 3GS handle them the same way, so don't worry about that. You can just write sphere geometry. It's going to be a buffer geometry. If you don't understand what I'm talking about, although you should understand, just don't worry, don't care about the buffer thing. So the sphere geometry, all right, we can put a mesh basic. Yeah, for now we are using mesh basic material. We're going to switch to mesh standard material a bit later, and we can use orange. It can be a string, no problem with that. If you want to provide always by injecting, you can do that, but it's a bit longer to write. Since orange is just a sphere, you can do that. Okay, so a mesh, sphere geometry, mesh basic material. Not working, I had to reload. Yeah, sometimes when something is a bit odd, you have to give it a little reload. And we want to move it on the left, so it's going to be position X. Or we can provide an array, it's up to you. I'm going to put -2 because minus for the X is going to be on our left. Okay, for the cube, we can put it on the right. Yeah, this one looks good. Position 2, yeah, everything like this is just fine. And we can remove the wireframe, offset wireframe false. It's up to you, like that. I'm gonna remove it because why not? It's a bit useful. And finally, we want to create the floor, so it's gonna be another mesh. For now, we put it at the center. We don't care. We're gonna move it once we can see something. So we create a plane geometry. Yeah, as you can see that I forgot to close it, so it closed automatically. So we can do that to automatically close. It's the same. You can let the closing tag, but it's useless because we can't put anything in here. Later we will have a geometry where we put something in it, but for now we don't really care. So we auto close it. Then we need the mesh basic material, so the usual, and we're going to create a green floor. So it's going to be green yellow because it looks a bit better, like this. And we have our floor right here facing us, so there is an issue. We can move it down a little, so position Y equal, I think it's, yeah, -1. Okay, then we can rotate it like that. Rotation X, I'm not checking the code below. I think it's minus math pi multiplied by 0.5. Yeah, got it right on the first try. This one is always a bit hard to guess. Do we put the minus or not? Because if you don't put the minus, you can't see it because you see the back face, and the back face is invisible by default. Anyway, every time I have to rotate a sphere, it's a challenge for me to know if I have to put the minus or not. And we want something a bit bigger, and we're going to put a scale of 10. Remember, when you put scale and a unit like this, it's going to be applied to the X, Y, and Z. We don't have to provide an array 10, 10, 10. And if you prefer to do it like this, there is no problem, you can. All right, nice. We have the scene. So I hope you succeeded by doing it on your own. If you didn't, don't worry. It's normal. It's brand new. Yeah, by the way, the order is not relevant. Like I can put the floor on the top. Don't do it. It's just an example. Yeah, I know this just broke, but if I reload, it's working. I don't know why that sphere always disappear. Not always, but sometimes disappear when there is a hot module replacement. I don't know what's happening. Anyway, I've put the floor on the top of the structure and we get the same result, all right? This is how 3GS works. 3GS will reorder things in order for them to look good. So we don't really care about the order. Anyway, let's move further. We have a scene. Nice. How do we animate that scene? Let me check if we did everything. Yeah, mesh basic material. All right, oh good. We want to animate that scene. The scene is already being drawn on each frame. but nothing is moving. Remember what I said earlier? Right now, nothing is moving, but the render is being done on each frame. So for me, it's 60 frames per second. We need to move things. And if we move things, they will be rendered with their new position. To start easy, we are going to rotate the cube using use frame. This is the first hook from React 3 Fiber that I told you about. Use frame. By the way, use frame, since it's one of those special React 3 Fiber hooks, can only be called inside of the experience component, because the experience component is inside the canvas. And use frame will be called on each frame, as you will see. First, we import it. Import use frame, or you can rely on the auto import if you want. It's gonna be at React 3 Fiber, like that. Make sure you have the same as me. You can save to make sure that there is no error. And to use frame, a bit redundant, we are going to, inside the component, call use frame and provide a function to it, like this. So I'm using an arrow function because it's easier to write, but you can use a classic traditional function. It's going to work too. All right, and this function will be called on each frame before rendering the scene. I can show you like this. Tick. Nice. We didn't have to create, if you remember from the previous lessons, that request animation frame that is calling the request animation, calling request animation frame again to call the same function and the same function, which was okay. It wasn't too hard, but right now you don't care about that. You can just use the hooks provided by React 3 Fiber, and in our case, the use frame hooks. And we're going to discover a bunch of hooks later. All right, that function will be called on each frame regardless of the current frame rate. So maybe yours is going faster. It depends on your frame rate, and we need to take care of that when we animate stuff, but we will see that later. So we have a function being executed on each frame. By the way, you might think that to animate an object, you should animate this attribute here, inside here. Like, I don't know, maybe create a state and update that state in the use frame, or maybe there is some states that are being updated every time, and then you put some rotation value right here. This is a big mistake. This is a big mistake because remember how React works. When you have a state, reactive data, so in our case, we are talking about a state that changes, the component will re-render. So everything you have here will be called again, and the virtual DOM will be updated, and the renderer will check, okay, that rotation changed, and it will rotate the sphere. But that's a lot of work, especially if you do it on each frame. To animate things, it's better to do it inside the use frame by changing the mesh directly, without relying on the React, flow, the React phases of rendering stuff, etc. It's going to be bad for performances if you rely on React. It's okay to have some re-renders, like, I don't know, you click on something, the color changes, and then we have a re-render of the component, and we see the result, and the color has changed. This is fine, but don't do it on each frame. Don't do it to animate stuff. And we will do this kind of stuff later, don't worry. But for now, we just want to make our cube rotate. We're going to do it the right way. And the right way is by rotating the mesh directly. And to do that, we are going to use a reference. Remember from the previous lesson, the React lesson, we used a reference to get the button and play with the style, which wasn't very interesting and relevant. But now it makes sense. We need the reference to get that cube and be able to update, to move that cube in the use frame. So let's go. First, we're going to import it. So I'm going to write it. Use ref from, and this is just React. All right, this is the reference. Use ref is from React, and we can use it inside React 3 Fiber. Then we're going to create a reference. I like to create the reference at the beginning. So here, cube ref. Remember that the ref is totally optional. You can call it cube if you want. Later in the chapter, we are going to remove that silly ref in the variable name. And we are going to use ref to call use ref. And then we need to associate that reference with the mesh. So I'm talking about this mesh here. So be careful, it's the box geometry with the medium purple mesh basic material. So it's the cube. In other words, I'm going to separate them a little. Yeah, like that. I like to have some spaces to be able to breathe a little. So we associate the reference by using the ref attribute on the mesh, because it's the mesh that we want to rotate, like this. If we save, okay, it seems to be working, we have no error. Great. Next, we want to rotate it, and it's super easy. Inside the use frame, so I'm going to remove that console log and say cube ref, and I'm going to do a small mistake. I'm going to do rotation Y. Classic mistake, I always do that. I forget that the reference, to access the actual element, we have to put current, right? It's inside the current property of the reference. So it's your reference, current, and that's the mesh. And this is a 3GS mesh, a native 3GS mesh. And I can show it to you. Maybe don't do it because it's going to be log quite a lot inside your console. So check that. This is a mesh, native 3GS mesh, so we can do whatever we want with it, like if it was native 3GS. We're going to do cube ref current rotation Y plus equal 0.01. And check that, the cube is rotating. So I'm going to reload to get rid of the console. And if you want to have some fun, check that, I'm going to increase it. Rotates faster, more, faster. And if I remove it, it stops. And it stops where it was at, because there is the hot module replacement happening. So see, it's rotating, rotating. I stop it. It just stops where it was. That's great. It's funny. Okay, we did a mistake. Did you guess the mistake? I actually spoiled you a little earlier. We did a mistake, and it's about the frame rate. Yes, if you put the same value here as me, you can test. Put the same value as me, check my screen, check the speed, the rotation speed of the cube. Now check yours. If we have the same frame rate, we have the same animation. But if you have, I don't know, some PC gaming setup with a very high frame rate screen, your cube is probably rotating much faster. I hope your cube is not rotating slower, because 60 frames per second is kind of the standard. So you should have the same at least the same animation as me, or probably faster. So it's the frame rate thing. We are updating on each frame. You have more frame per second than me, so the cube is rotating faster. I'm not going to spend too much time on it because we saw that in the previous lesson. So we need to know how much time has passed since the last frame. It's the delta time, you know, since the last frame there was, I don't know, like 60 milliseconds. I need that value to be able to know how much I should rotate the cube. And good news, we can access this value just here. We can add some arguments. We need to get access to the second argument. The first one is a state thing. We're going to talk about that later. If you're curious, you can log it. We see that it's full of things. Hey, see that? There is a bunch of things there. Very interesting. We're going to use that later. So we don't care about the state. All we care about is the second argument, and it's the delta time. And you can just write delta. You can use whatever name, by the way, but I like to call this one delta. And if I reload, see that? Nice. And this makes sense because those are seconds. So I have something like 16 milliseconds. It makes sense because my screen is running at 60 frames per second. If you do some mathematical operation, you will see that this is normal. All right, cool. And maybe you have different values. Anyway, now we know how much time has passed since the last frame. And we can use that delta on the rotation. Let me check. Yeah, we can use it just like that, like delta. And see, it's rotating. And it will rotate at the same speed for everyone. And we get access to the delta just like that. And we didn't have to do some silly calculations to get that. Nice. Like in 3GS, we can group objects together with the group class. I think we already talked about this one a little earlier. We're going to group the cube, so the cube and the sphere, not the floor, and then animate that group like a carousel. And now, if you want to try on your own, is a good opportunity. It's not too complex, but it's kind of, you will practice what we just learned. So try to put the cube and the sphere inside a group, and then you make that group rotate. So you get something like that. All right, it's rotating like that. Let's go. And now we do it together. So I'm going to create a group around the sphere and the cube. So it's just like that, group, and I put it inside that. So the indentation, you do whatever you want. If you do that, it's going to work, but please put some good indentation. Do some effort there. It's a clean code basics. Do the right indentation, always. And if you have an issue, don't present code with bad indentation to me. I'm not going to help you. That's the minimum. Then if we want to animate, since we want to animate it, we need a reference to that group. So we're going to create that. We're going to call it group ref. Again, the ref is totally optional using the use ref. Great. And then we can associate it with the group using ref attribute and group ref. We save just to make sure that we have no error, right? Seems fine. Then in the use frame right here, we're going to make it rotate. So it's group, ref, rotation, and I did a mistake. What's the mistake? I forgot the current. Yeah, I did it on purpose, this time at least. Plus equal delta, and it's rotating. Yay, it's working. Nice. Easy. We did that just to practice. We're going to get rid of this one. Yeah, by the way, let's remove this one because it's rotating way too much. You can give it a little reload so that they are at their initial position. It was just to practice a little. Remove that animation, you're going to get sick and distracted. Nice. When I try to rotate around, it's not working. Because it was working in the previous lessons, because we had the orbit controls. Can we get our orbit controls back, please? Well, yes. Yeah, implementing it ourselves is more complicated than adding a mesh. Oh, shoo. So adding a mesh is super easy. Adding the orbit control is a bit harder, but we will see a much faster solution in a later lesson. All right, I'm showing you the hard way so that we practice, we learn features along the way. In the next lesson, maybe, I'm not sure, you're going to see a very easy way of adding the orbit control. It's going to be super easy. For now, play the game with me. We are going to do it the hard way. If you remember from the lessons, the previous lessons, when we were doing native Java 3GS, the orbit control isn't part of the default 3GS class. By that I mean the 3 variable. You know, when we import everything as 3, orbit control is not part of it, and we had to import this very specific class, you know, from the 3/GSM JSM/examples or something like that. So it's a bit harder. This means that orbit control, we can't just create it like that. Okay? Orbit controls. We can't do that because it's not part of the native classes. React 3 Fiber didn't add it automatically. For good reasons. It's quite a big class. We don't always need it, so it's not added automatically. We're going to import it and then convert it to a declarative version so that we can write something like that. All right? React 3 Fiber didn't do it. We are going to do it ourselves. So first, we need to import it. Remember that we added the 3 dependency to the project. So we can do import. That's the same import we had in the previous lessons. Orbit controls from, and it's going to be 3/example. I got the path wrong. It's example JSM controls orbit controls. So long to write. What I'm going to show you in the next lessons, you're gonna love it. So much easier. We save just to make sure that it's working. Maybe you can log it. All right, this is the class. This is the native 3GS orbit control class. It's already so long to write, and it's just the beginning. Next, we need to import the extend function from React 3 Fiber. And the extend function, so it's going to be here. So React 3 Fiber, it's going to be right here. The extend function is what we use to create new declarative elements to React 3 Fiber. All right, so that we can write something like orbit control, orbit controls, something like that. If you want to write this, you need to use the extend function. I'm going to show you how to use that extend function. It's quite easy. Extend will automatically convert a 3GS class into a declarative version and make it available in the JSX. That's exactly what I told you. To use the extend, we need to do extend and provide an object. And here you will put everything you want to convert. You can convert multiple things, but in our case, we just want to convert the orbit controls class to a declarative orbit control. So we're going to put orbit controls, and we're going to provide the same thing, okay? Because it's an object. You might think, why do we have to put an object like this? Well, it's because you choose the class here, and you choose the name you want as the declarative version here. In our case, it's the same. You don't have to put it in camel case, okay? React to Fiber will take care of that. You can put the same name here and here. And the cool thing when you do that in native JavaScript, when you have the same, when you are inside an object, so the object is right here, and when you have the same property name as the value, you can just write this, just like that. It's the same. We get the same result, so it's shorter. Nice. Yeah, that's what I said. Okay, cool. Next, in here, we can create it. It's not that simple, unfortunately, you will see. So orbit controls, and I'm going to auto close it, and I save. And we get an error here. Oh no, what did we do wrong? By the way, there is a console log. Oh no, okay, I got rid of it. So there is an error, don't worry. It's because we forgot that we need to provide stuff to the orbit control. If you check on the documentation, orbit controls, right here, when you create an orbit control, where is it? Yeah, right here. You need to provide two things. You need to provide the camera and the DOM element so that the mouse can grab on something for the events. Okay, cool. Usually we provide the canvas we can get from the renderer DOM element, but you can provide also a div on top of it or whatever. So right here, we didn't provide any of those, okay? We need to provide those as the constructor values. So it's going to be something like args and stuff, but let's not do it yet, because first we need to get access to the camera and some DOM element. We can find them, and we already saw where to find them. Don't do it. I'm just going to show you. Don't do it. Remember when we logged the state? Check that. Let me remove the orbit control, because don't do it. Just check my screen. Yeah, see that? The state contains a lot of things. Let me check if we talk about this. No, not yet. So the state, there is some clock controls, there is null, camera, events, GL, some mouse thing. Well, the scene, okay, it seems like there is the scene, some size thing with a set size viewport. There is a bunch of value in there. And if you check closely, there is the camera, which is a perspective camera. And if you want your WebGL renderer, it's right here as just GL. Okay, so using that state, we can get access to those two things that we need. If you get access to the GL renderer, to the WebGL renderer, you can get access to the canvas. But this here is inside the use frame. We don't want to get the camera and the WebGL renderer on each frame. We just want to get them once at the beginning so that we have something to provide to the orbit controls when we add it to the GSX. So what we're going to do, I'm going to remove that. Do it too if you add it too. And we want to retrieve those values by using a new hook, so a React 3 Fiber hook, which is use3. And use3 will provide us the same state, but only once at the beginning of the component. So it's just one, we can just retrieve it like that. So we are going to import it. So I'm going to add use3 here. So it's from React 3 Fiber. Make sure that you import from the right library. I save it. And then in my component, so I can put it at the beginning right here, I'm going to do const, I'm going to call it 3 for now, equal use3, just like that. And then you can log it and check that in the console. You get this. So be careful. If you added the orbit control, it's going to bug because we didn't provide the camera and the DOM element. So maybe comment it so that you don't have an error. And as you can see, when you log what you get from use3, we get the exact same state. All right, we get that state thing. And in there is the camera and there is the GL, so the WebGL renderer. Nice. Also we get the clock, and we're going to use it later. Yeah, by the way, check that. Where is it? The clock. So see, yeah, the clock. We're going to use that later. Anyway, You can destructure it if you want specific values from it and not everything. It's up to you. You can do whatever you want, but we can destructure it so it's an object. So we need to put some curly bracket, and we want the camera and the GL, just like that. You can test them, camera, GL, and check that. I have the perspective camera. I did a mistake. No, and the GL is there. It's because there is two renders. So the perspective camera and the GL. And there are two renders, which is why we get them twice. Two component renders. All right, nice. Now we get back. We can remove the logs. We have the camera and the GL. We get back to our orbit control. So add it if you didn't add it yet. And since we need to provide those as the constructor parameters, we can just do args, like any other decorative components. Provide an array. And I'm going to provide the camera first, and then the GL DOM element, because we just want the canvas. Okay, it's not the WebGL renderer, we want the canvas. It could have been a div or something else, but let's follow the documentation of 3GS and provide the DOM element. I'm going to save, and now check that. I can rotate the camera. It took a few minutes, but it's okay. I mean, it's not too complicated. Don't worry, it's going to be much faster soon. But let's baby step, let's do step by step. Yeah, let's talk about lights just a little, because we have a full lesson about lights, shadow, environment map and stuff like this. And it's a really cool chapter. You will see that it's so cool. I'm not going to spoil this part. Let's make our scene more realistic and add some light. So let's go. How do we add a directional light? So the order, again, is not that important. You can put the lights wherever you want. I like to put kind of logic components at the top. So orbit controls is more as logic. Then environment components next, and then the actual scene. So I'm going to put the lights here. You can do whatever you want. So directional light, and I'm going to close it. What do we get? Same result, a bit weird. Well, it's because we are using a mesh basic material. Remember from the previous lessons? I hope you remember that. But the mesh basic material is just like a color, or just a texture, without shading, without shadows, without lights and stuff. So we need to change that, and we're going to replace all mesh basic material by mesh standard material. So let's go. This one we replace by mesh standard material, mesh standard material, and mesh standard material. So for the sphere, the cube, and the floor, and we can reload and we get some shading. Nice. It seems that the light is above, and yeah, that's the case. The default light comes from straight above. To change a directional light, if you remember, think of it like it's targeting the center of the scene. By default, it's above, so it's gonna light things down like this. And if you want to move the light, you move the light itself using position, and it will keep looking at the center. And we can actually control where it's looking, but we are going to keep it at the center and just move the light like this. All right. So let's go. It works just like for a mesh. We can set position. We can send an array, okay, because it's a vector of 3. So X, Y, Z, we need to send an array. And we're going to put 1, 2, 3 because we are lazy. Nice. And it seems to be working. So easy. It doesn't look perfect, but we're going to change it a little. We can access the other properties like the color or the intensity. We're not going to change the color, but if you're curious, you can put, I don't know, like red, and now the color, the light is red, which looks a bit weird. So I'm gonna get rid of that one. We can change the intensity and put, I don't know, like 1.5 so that it's a bit stronger, and I think it looks better. So without the intensity, we had this. Oh, sorry. We had this. Yeah, sometimes you need to reload. Remember that. And with the intensity to 1.5, we get something a bit brighter. Next, as you can see, well, the shadow, the core shadow, the part of the meshes in the dark are really, really dark. So it's not very realistic and it doesn't look really good. We want to lighten this part a little. So we're going to add a ambient light. To add an ambient light, well, you can put it after. Doesn't matter much. Ambient light, and ambient light also have an intensity. We're going to lower it to 0.5 so that it's not too strong, and check that. Now it's working. The part behind is lightened by the ambient light, and the part in front of the directional light is much brighter, and it looks good. And we're going to talk about, to explain why it looks good like this. We could go further and talk about other lights, environment maps, shadows, etc. But this will be for later lesson, as I said earlier. So next, a topic a bit harder. We're going to create custom geometries. So creating a custom geometry is a bit harder, but still convenient once you understand how it works. If you remember from the 3GS journey, 3GS native lessons, it was really hard. You remember the process? I'm going to explain in detail. I think we have a whole lesson about that, creating custom geometries. It's a bit hard. We're going to create a mesh with its geometry composed of random triangles. All right, it's kind of the classic dummy exercise. It's the hello world of the geometries, just random triangles. And you will see that we are going to discover a bunch of features along the way. Let me remind you how we do that in native JavaScript. First, we create a float32 array. We put a bunch of value in it. Then we create a buffer attribute using that float32 array. And then we add that attribute, the buffer attribute, to a buffer geometry. Remember that? For the galaxy, as an example, it was a bit complicated. And we need to do that now in React 3 Fiber. So it's quite interesting how we do that here. It works the same. We need to do the same things, but how do we associate things together? First of all, to practice a little the fact of separating components, we're going to create a component just for that. Let's go. So I'm going to open the sidebar again. Not the sidebar, yeah, this one. You can create a new component. So I'm going to call it custom object. Why not? .js. And in there, we're going to do the usual thing. So we export a default function that we name the same. So custom object, like this. And in there, we're going to return null. Okay, I didn't put anything yet in it. If you remember from the previous lesson, when you put null, it works, but there is nothing. Great, we're going to put some stuff in here right after. Back to the experience.js, we're going to import it. So it's going to be import custom object from object, yeah, like this, from custom, sorry, /custom object.js. All right, let me log it because I'm not sure I wrote it perfectly. Yeah, it's working. Nice. And in the JSX, I'm going to put it at the end, although it doesn't really matter. We can add it like this and auto close it. We save, no error, which means it's all good. There is nothing on screen because we put nothing in there. All right, it's null. Back to the custom object.js file, we're going to create like a very simple mesh just to make sure that our component is working. So we create a mesh. In that mesh, we're going to create a box geometry. Later, it's going to be a custom geometry. No parameters, we don't really care. A mesh basic material with the color of red or whatever, it doesn't really matter. Like this. Use a mesh basic material, not a mesh standard material. You will see why a little later. All right, it's working. Great. Make sure that you have the same thing and that you saved every files that we changed. So we use a box geometry. We now need to use our custom geometry. By the way, whenever something becomes complex, if you want to reuse it or if it makes sense to separate it, you should create a dedicated component. What we just did here, created a custom object, you should do it every time your experience.js or whatever class component name you use become complex. In the following lessons, we will try to stick to only one component so that we have everything in one file. But every time things get a bit complicated, create a different component so that you can reuse it, so that you separate the logic and it's a lot easier and you understand your app much easier. Like right here, we know that it's a custom object. Okay, for a good example is the very last lesson of the chapter where we create a game. We are going to create a bunch of separated components, some of them in the same file, some of them in a totally separated file. And yeah, you will see that it's very important. Otherwise, the application would have been quite messy. All right, nice. Next, we want to create, so remember, we need to create an array. So it's going to be the position of the vertices. remind you that we want to create just a bunch of triangles so that we can test custom geometries. We go back to the custom object if you're not already in the custom objects, and we are going to, in here, so inside the function, we're going to create const vertices count. We just want to know how many vertices there will be. We're going to create like 10 multiplied by 3, meaning that we want 10 triangle, and since one triangle is 3 vertices, well, we multiply it by 3. All right, I'm going to go quite fast on that because this is the same as we did earlier in the previous lessons, but still I'm going to explain everything. Then we need to create a float 32 array. Remember that type of array? It's a bit weird. Those are very optimized, but a bit hard to handle. But we need to use them. So we are going to create it. So it's going to be const positions with an S. You can put without an S, it's up to you. It's going to be, we're going to do new float 32 array. And we're going to put vertices and do, vertices count multiply by 3. What? Again? Yes, because remember that, okay, we have 10 triangles. We need 3 vertices per triangles, but each vertex needs 3 values because each vertex, so a point in space, it's X, Y, and Z. Okay, so 10 triangle, 3 vertices per triangle, so that's what we have right here, and then 3 values per vertex. So it's a lot, I know, but that's why we need to multiply it. So the array, we need to multiply the vertices count by 3. Next, we need to fill that array with random value. We don't really care. We just want a bunch of triangles. It's not a very specific shape. So I'm going to do a classic loop. So let I equal 0, I less than vertices count. Vertices count multiply by 3. Yes, because we need to fill that array. So it's the size of the array. So multiply by 3. There are many ways to write all of this. You can create more variables or whatever. I++, so we are looping over that array amount, I mean the length of that array, and then we put some stuff in here. So I equal, I'm just going to do like a math random, so math random. So math random is from 0 to 1. I'm going to put it back a little, so minus 0.5. So right now we have something from minus 0.5 to positive 0.5. Okay, so we had math random which were only positive. Now it's also negative. So it can be minus 0.5 to positive 0.5. And then we multiply this, so we put it in parentheses, by 3 so that it's a bit bigger. Otherwise it would be a very small area of triangle. I'm not going to explain this in details. You get the idea. It's just random triangles. We save. All right, it seems to be working. At least we don't have any error. Next, we need to create the buffer geometry and the buffer attribute. So first, let's switch to a buffer geometry like this. And I save, and the plane is gone because we have our custom geometry, but there is no vertices in here. To provide the vertices, where this time, see that I'm going to not let the auto close, I'm going to close it myself so that I can put stuff in here. Yeah, follow me on that. It's a bit tricky, but it will make sense. And inside that buffer geometry, we want to add a buffer attribute. So we're going to create buffer attribute like this, and this one can be auto-closed. A bit complex. Okay, nice. So we have a buffer attribute, which is supposed to be in the buffer geometry, but we are not using the positions yet. So we still have nothing on screen. What we need to do now is to tell React Free Fiber how to attach this buffer attribute to the buffer geometry. Remember the attach thing? So we're going to say that you attach, so React Free Fiber will create an instance of buffer attribute. And we need to set to attach to, and check that, it's going to be attributes dash position. If you save, I think we get an error. Let me check. Yeah, we get an error. So be careful with that. Maybe don't save yet because 3GS can't render anything. Right now it's attaching an attribute which is empty. So the scene is messed up. When we wrote attributes dash position, check that. It's like doing this. So we wrote attributes dash position. inside our geometry, so because this is inside the geometry, it's going to do geometry dot attribute dot position, and it will put the buffer attribute inside. It will assign it to that property. I know it's a bit weird. There is some abstraction going on here. It's a dash which gets converted to a dot, so it's the property inside the property, but it will work. You will see. All right, nice. Now we need to provide more values because we still haven't provided the position vertices. We need to provide 3 values. First, we need to say how many vertices there is. So it's going to be count, and we need to set it to, I'm not sure, I think it's this one. Vertices count. Yeah, quite sure it's this one. The item size is how many values in there should be used for one vertex, x, y, z. So it's 3. So item size is going to be 3. And finally, we can provide the positions. It's going to be array and positions with an S. We save and we get our triangles back. Your triangles are probably different because it's random, but you get the idea. So our triangles, we can't see much of those triangles because, as you can see, like focus on one triangle. If you check the other side, well, we can't see it. Like this one here, back, we can't see it. So we can fix that quite easily, just to practice a little. We need to set the side of the material to double side. All right, this is the native JavaScript way. So how do we do that in here? Well, we need to do something like side, and we provide double side. So how do we do that? We don't have access here to 3 double side. So we need to import 3. So I'm going to remove it for now so that we don't get an error. And at the top, we're going to do import all as 3 from 3, just like that. And now we have access to all the classes and constant, etc. So in here, we can provide the side. So side equal 3 dot double side. So both sides of the triangles are going to be visible. And now we can see all triangles from both sides. And it's working a bit better. Nice. By the way, if you prefer, you can import very specific classes like import double side from 3. You can do that and then use that double side only. If you prefer like this, just do it. There is no issue with that. I'm not a big fan because I like to know where things are coming. But if I put 3, I know this will always come from 3. It makes a bit more sense, but you can totally do it if you prefer. Sometimes we will do it just to vary a little the way of coding. Next, optimize vertices with useMemo. Yeah, this one is interesting. Remember useMemo? We're going to use it right now. We made kind of a mistake. The code inside the custom object, so I'm talking about this code, will be called every time the component needs to be drawn, needs to be rendered. It's more like render, not really drawn. So every time there is a state, a reactive data that changes, this code will be called again. In our case, it's no big deal because our component, there is nothing in it. There is no reason that for the component to be a re-render. But maybe you will start to have some props and start to have some states variable and things like that. So we are going to act like if we need to optimize it and make sure that those vertices are not being created again and again, especially since you might have geometries with a lot more vertices. Having this much vertices, I mean, it's 10 triangles, it's nothing. But sometimes you get thousands or millions of triangles, so you need to optimize it. This is where useMemo comes to the rescue. useMemo is a React hook, so quick reminder, if you did the previous lesson, you already know about useMemo, but let's see it again. Is a React hook to which we send a function. It will call that function and remember the value. So the function will return something. In our case, it will return the position, and useMemo will memorize that value and it will keep it. Next time useMemo is called, it won't call that function again. It will directly return those values that useMemo saved. all right? So that we are not calling the same values again and again. So the triangles will keep the same position and the array will stay the same. And if you want to break that kind of cache, you can specify some dependencies. So it's the second parameter of useMemo. We are going to do it right now together. But if you provide an array to useMemo, and here you will be able to set the variable that if those variables change, that it will break the cache, and useMemo will call your function again to get a new array or whatever you are providing to useMemo. Let's put it into practice because a lot of words aren't very easy to understand. So first we need to import it. So import useMemo from React. All right, nice. Next, we're going to put it right here. Okay, so I'm going to do a mistake. Don't save here because it's going to break. I'm doing const positions. So that's the mistake. We have two positions, but we are going to put this one inside useMemo right after. Equal useMemo. So we are calling useMemo. And if you remember from the previous lesson, we need to provide two things. We need to provide the function that will return, in our case, the positions. For now, it's empty. And then the array of dependencies. And if you put an empty array here, it will just save the value and keep the value forever. Okay? So next, inside that function, yeah, by the way, for the dependencies, there might be one dependency that should break the cache, and it's the vertices count, right? Maybe we should put this, but here's the thing. Vertices count is just a number. It's 30. So it doesn't really make sense. This is not a state. This is not a prop. If we had like a prop, like custom geometry, and we put the prop right here, which you can try after this this section, you can try to have a prop and then set it from the attribute. In that case, you should put vertices count here. But since it's a fixed number, it doesn't really make sense. So I'm going to let it empty. All right, cool. Next, check that. We are going to take this part. Watch my screen. Only the position things and the thing and the loop. I'm keeping the vertices count outside because we are using it here. Okay, so leave the vertices count outside of useMemo, and all you have here, so the position, so the float variety array and the loop, you put it inside that useMemo. So we are doing the calculation of the new vertices inside the function we send to useMemo. And don't forget to return it, because it needs to return that value. So we return the positions. Let me explain again. useMemo, we provide a function. This function will return the positions, and we save those inside positions right here. And we ask useMemo to save those forever. All right, because we set the array as empty. Be careful, I think if you put nothing there, it's like useMemo is not working. So it will break the cache again and again, although I'm not sure. So provide an empty array like this. If we save, we have the same result. But if the component is being re-rendered, it will use the old value, the saved value. It won't do this calculation again and again. Nice. Yes, by the way, for those that are used to React and more advanced techniques, actually it's not that advanced, be aware that you can do kind of the same thing using a useState. All right? I know you can do that. I know we can do that, but we are not going to do it because we are going to do it later. I just wanted to show you the useMemo in that case. Okay, nice. Next part, you are going to compute vertex normal. Because if you switch to a mesh standard material, so now is the time to test a mesh standard material instead of the mesh basic material, it doesn't look really good. Yeah, something is wrong. We put a mesh standard material, meaning a material that should react to light, all right? But everything is dark. In the older version of 3GS, everything was red, so I don't know what they changed exactly, but I think it's the default normals. Maybe now they're pointing down, or there is no normals, or I don't know exactly. Anyway, there is an issue. The issue is that, yes, I told you the normals are not set. If you remember from the previous lessons, the normals are kind of 3D coordinates applied on each associated with each vertex, telling where is the outside. So that if you have like a triangle like this, the outside, you set it like this. If there is a light here, that triangle will be lightened quite strongly. But if the triangle is like this and the light is above, well, the triangle will be darker. And we didn't provide those normals. So there is a missing data right here. First solution, we could provide those normals and do some complex mathematics and send a new array and create a new buffer attributes. It will take maybe half an hour. So let's not do that. Instead, we are going to ask Three.js to just calculate the normals. All right, much easier. It's just one function to call. And Three.js will take the vertices and check, okay, there is one vertex here, one vertex here, one vertex here. Okay, the normal should be here. And if the last vertex is below, the normal should be here. So it's automatic, much better. So first of all, compute vertex normal, we need to call that on the geometry. So this one, how do we get access to this one, to the native instance of the geometry? We're going to use a ref. Yes, as always, it should be a reflex. Like you want to access the native class, the native instance, you need a ref. Use ref from React. Make sure you are importing from React. We save. And then we create the geometry reference. So we can do it here. We could have taken the mesh and then target the geometry of the mesh, but let's target the geometry itself. So I'm going to put it at the beginning. So geometry ref, as always, where ref is optional here. Use ref. So we've created that ref, nice. And then we associate it with the buffer geometry by using the ref attribute, like that. We save, and it seems fine. Nice. I'm going to do a small mistake. So you can do it with me or just follow the video. I'm going to do geometry ref. I don't forget about the current this time. I'm going to do compute vertex normal. Don't save yet. Don't save yet. All right, I haven't saved. Normals with an S. First mistake. So I haven't saved. Will this work? I'm gonna save. Check that. It worked. Nice. So what's the mistake? Give it a reload or just watch my screen if you're not doing it with me. And now there is an error. Can you guess what happened? The first time it worked, so I'm going to remove it because see that the geometry is already here. It exists. And then we added this code. React will call everything in there and called compute vertex normal, and the geometry was already in the scene. So it worked. We save, the geometry existed and it's working. But when you reload, so on the first render, the ref, there is nothing in there because the GSX hasn't been rendered into a Three.js. There is nothing when you execute that. Actually, I can show you. Let me log it for you. See that? Undefined. So we did a mistake. We need to wait for the first render to be done. And do you know what we should use to do that? Remember from the previous lesson, we need to trigger some instructions after the first render. We need to use ref. Use effect. Damn. So it's gonna be use effect. Why did I say use ref? So use effect, we import it from React, and then we use it. So I'm gonna comment those here, and we can do it. Yeah, why not? After the use memo. It's not that important. So we call use effect and we provide a function. And as the second parameter, we provide an empty array. Why an empty array? Because when you provide an empty array to use effect, this function will be called only once after the first render. Only once. And we need to compute the vertex normals only once. So you do that. So let's do some refactoring. So I'm going to put that here. And I'm going to take this and put it there and uncomment. So we wait for the first render to be done in order to log the geometry because I'm curious to see what's in there, and then compute the vertex normals. And we can give it a reload to make sure. And as you can see now, we know that we have access to the buffer geometry because the GSX has been rendered. And this code will be called only once. Okay, we can get rid of the console log. Yep. Okay, this is done. This is done. All right, nice. We're almost done. We have so much more to see, but mostly in the next lessons. We have a few more things to see here. Some quite interesting things about the canvas settings and the default settings. So the canvas component is setting up, so let's get back to the index.js file, is setting up a bunch of things for us. We just created a canvas and suddenly we have a scene, a camera, a renderer, anti-alias, encoding, etc., etc. And it looks good with minimal effort. We just added a canvas. That's so cool. So cool. But sometimes we need to change those things. Like if you're not happy with the camera position, default position, the field of view, the anti-alias, you want to remove it for some reason, or you want to play with the pixel ratio, or you want to change the encoding for some reason, you need to change those. Do not worry, we have access to everything and we can change everything quite easily. So first, let's talk about the camera. We can change its setting and its position easily. First, we need to specify a new attribute. I'm going to put some line break and set camera equal, and we need to provide an object. So curly bracket inside curly bracket. Then it's the usual properties of a camera. If we want to change the field of view, we can provide field of view, so FOV, and we can put 45 degrees. We save, and as you can see, it's zoomed in. If we want to change the near and far plane, you remember it's where things start to clip, like something that is further than this far value will just not be rendered. So we can do near 0.1, far 200. Why not? It should not change anything because the scene is quite close to the camera. Then we can play with the position. Yeah, why not? We set position and we provide, since the position is the vector 3, we provide an array 3, 2, 6. I don't know why. Let's see where we get. Okay, we get there. So the default position, we can still rotate around with the orbit control, but the default position of the camera will be those coordinates. And it's working. No big deal. And yeah, I put some line breaks. You should keep your code clean and easy to understand. It's up to you. Sometimes it's better to have stuff in one line. Sometimes it's better to have stuff in multiple lines. It's on you. We can also change to an orthographic camera. If you remember the orthographic camera, it's right now we have perspective, meaning that if something is far, it's small. If something is close, it's bigger. The orthographic camera will render the scene, but without this depth effect. So how do we do that? It's crazy easy. Orthographic, and it's done. Nice. But where is my scene? Check that, it's there. We can zoom in a little and we can see it. Oh, what a bummer. If you remember, so it's working, that's great. We have the orthographic camera, but everything is a bit small. And see, there is no perspective. Like I can get like this. See the size of the sphere? It's always the same. Okay? So it's always the same. There is no perspective on the cube. Okay, nice. But at the beginning, we are way too far. So how can we fix that? If you remember from the previous lessons where we tried the orthographic camera, I think we did, you have a left value, a right value, a up value, and a down value, a bottom and up, something like that. And it will be kind of a parallel render of your scene. And if you make them tighter, like this, well, objects will by default looks bigger. But React Free Fiber is already handling those. React Free Fiber is already modifying those, especially when we are resizing the viewport. React Free Fiber will make sure that the left, right, and stuff will make sure that everything is still clean on the screen. So we should not play with those values. We can, but it's going to be harder and it's going to break what React Free Fiber is doing. Instead, there is a much easier solution. We can play with so the field of view is not working anymore, but let's keep it. It's not being used, but let's keep it. We can play with the zoom and we can set a zoom to, I don't know, like 100, and now it's working. Just like that. 100, it's the default zoom. Actually, when you scroll, it's changing the zoom. So you're kind of setting the default zoom. The orbit control, when using an orthographic camera, it won't move the camera. It will actually play with the zoom like that. All right, nice. Containing the setting. Yeah, by the way, if you want, like, it's a lot of code inside there. Don't do it. Just watch my screen. I mean, you can, but it's not that interesting. If you have a lot of code and you want to avoid that inside the JSX, you can create a separated object like camera settings. You put everything here, so it's an object. Don't do it if it's not that interesting. And you put it there. Okay, so that you keep minimal stuff right here. This is just JavaScript. I just reload and it's still working. So we are going to get back to the what we had before. All right, nice. Okay, I like the orthographic camera, but I prefer the perspective camera. So I'm going to remove that orthographic, and we can also remove the zoom. Do it with me. Remove the orthographic attribute and remove the zoom property so that we get back to our camera with perspective. Next, animating the camera. Let's have just a bit of some fun with the camera. Right now we added the orbit control, but we are going to do a small exercise and try to make the camera rotate around the scene, but keep looking at the center of the scene. All right, how can we do that? First, we're going to remove the orbit control. All right, nice. We can't, I'm drag and dropping right now, it's not working anymore. We will put it back later. It's just a small exercise to have some fun and try to animate stuff. The first part, so let me check. Yeah, to do that animation, if you remember, we did some trigonometry in the previous lessons. We want the camera to rotate around the center of the scene, so it's a circle, all right? So it's a circle on what axis? Can you guess? It's a circle that will move on the X and on the Z. Right, not the Y. We don't want the camera to go up and down. We want to do something like that. And we are going to use a sinus and a cosinus. I'm not going to go into details of that trigonometry things because we already talked about that and that's not the topic of this lesson. But if you want to move something on a circle like this, you create an angle, I don't know, that goes from 0, 1, 2, and it keeps going up. And you provide it to a sinus and a cosinus. And you use that sinus on the X, it's going to do that. And on the Z, it's gonna do the cosinus on the Z with the same angle. And when you combine them, so the X doing that and the Z doing that, you get this. All right, that's the idea. I'm not gonna go into details, although I really want to explain and do some drawings. That's not the topic. So first of all, we need to get access to the camera. How do we get the camera? We are going to do the animation in the use frame because we want to animate it on each frame, which actually makes things quite easier. Because right here, remember that state variable, we have access to the camera in that state variable. So I'm going to log the state. It's been logged on each frame. Okay, why not? And if I open, let's say this one, as you can see, there is the camera in there. So I can just do state.camera, just like that. And now we have access to the perspective camera. You can do a quick test, like if I do state camera position.x plus equal, let's use the delta. It's moving. Okay, great. But we don't want to do like a translation like this. We want to do that circle coordinate thing. So I'm going to remove this and remove that. I just know that I can access the camera from here. Okay, nice. Let's reload. Next, we need that angle. So that angle that it increments. We are going to use that angle on the sin and the cos to get the X coordinate and the Z, because it's like that. We don't want the camera to go up. We want the camera to go forward, backward, and sideward. I'm not sure we can say that. Anyway, you get the idea. To get an angle, we can use the elapsed time. By that, I mean how much time has passed since the beginning of the experience. There are many ways to get this kind of values that just increment with time. We can use date now or things like that. But I want to show you this solution because we are going to use the clock. And I've shown you that clock earlier. See that state? So we get the camera from that state, but we can also get a clock. State.clock, like this. And this clock is a 3GS clock. We talked about this one already. I can show you there. It's this class. And this class has a bunch of things like the delta time, the elapsed times, etc. And we are going to use this one. And to get the elapsed time, well, it's quite easy. It's state clock. So that's an instance of our clock. And we can just add elapsed time and check the value in the console. Those are seconds. 3, 4, 5, 6, 7, and keeps going up. Nice. So we get access to this. By the way, we can also use I'm going to show you. So it's a get elapsed time method. See, I added get at the beginning. I changed the E to uppercase and I added those parentheses here because it's a method. You need to call it. I'm going to save. And as you can see, we get the exact same result. I don't know if there is a real difference between those. For now, let's use the elapsed time, just the elapsed time. So we have the camera, we have the elapsed time. Let's do some trigonometry in order to calculate the position on a circle. I'm going to remove those, comment those log for now, because it's messing up with my console. So let's go. It's going to be state.camera.position.x. Remember, we are moving on the x and on the z, so that it does a circle like this. Equal, we're going to use a sinus on this one. You can invert them. I think it's kind of the same result. It's going to maybe rotate in a different direction, but you get the same result. And we use an angle, and I forgot to set the angle, my bad. So angle equal, and we use the state clock elapsed time, just like that. All right, the angle, we get the elapsed time. It's just like 0, 1, 2, 3. And we use that angle on the sinus for the x, and we use that angle on the same angle on the cos for the z, just like that. And check that. I'm going to save. It's going to be a bit weird, but it's working. All right. It seems to be doing a circle. So you have your scene. The camera is around here. The camera is still looking the default direction, and it's doing some small circles like this. Okay, nice. If we want to do bigger circles, we can simply multiply the sin and the cos by a bigger value, and we get that. So it's behind us, and we do a full circle, and then we come back. It goes behind us, and we are almost done. Maybe you can guess what we need to do to make the camera look at the center. Spoiler alert. Yes, we need to call the look at method, which is a method that on every object, camera is an object. This is just 3JS. There is a look at method on every object. So state.camera.look at, and we're going to provide the center of the scene. So 0, 0, 0. We saved, and check that. We have an animation. So we lost the orbit control, but now there is an animation running with the camera. It was just a small exercise to show you that you can still access to native 3GS things and have some fun with trigonometry. If you want, you can make, I don't know, the camera goes up and down using one more sinus or whatever. We're going to remove that before we get sick because it's moving way too much. So I'm going to comment that and put back the orbit control. All right, do that with me. Comment the animation we did in the use frame, just the animation for keep the cube animation, just comment the animation for the camera, and put back the orbit control so that we can rotate around like this. Next, about the canvas, because we were talking about the canvas, the camera, and things like that. The anti-alias. As I told you earlier, the anti-alias is on by default, so it looks good. You know, the anti-alias, it's to prevent the stairs effect on the side of the geometries. It's on by default, and you can deactivate it. And to deactivate it, you need to provide a new attribute here. So it's going to be GL. It's going to be an object, just like for the camera. And in here, you can provide a bunch of parameters related to the WebGL renderer. So for us, it's going to be anti-alias, and we can set it to false. And as you can see, it's a bit clear. So maybe with the video compression, you can't see it on my screen. So test on your screen. Make sure you wrote it right. So anti-alias false. Maybe give it a little reload. I didn't have to do it, but maybe you need to do it. And it looks bad. All right, because the anti-alias, the aliasing is quite bad, and the anti-alias is doing quite a good job. So let's put back true. I just wanted to show you that you can deactivate it. Maybe you need to gain performances and you don't really care about the anti-alias. In that case, you should deactivate the anti-alias. Next topic is the tone mapping. Do you remember what the tone mapping is? React 3 Fiber sets the tone mapping to ACES Filmic tone mapping, which I think too is the best tone mapping, and it looks really good. If you remember the tone mapping thing, it's not a true tone mapping. By that I mean that tone mapping is when you have like a picture where you have data for the various pixels, and they are in high dynamic range, meaning that it doesn't go from 0 to 1 or from a range from 0 to 265. It's like light values that can go up. Like if you watch the sun, it's going to be a very high value. And if you watch, I don't know, like the keyboard on your computer, well, it's going to be much smaller. And those can't be really seen. It's just like intensity values that go beyond the classic ranges. Then you take that picture, those values, and you clamp them and you compress them the right way to get something that goes from 0 to 1, something that we can see. All right, that's what the tone mapping is doing. When setting a tone mapping, at least by default, without processing or complex stuff, it's kind of a fake tone mapping because it's not really like high dynamic range. It mimic the effect when you get from a high dynamic range to a low dynamic range. But it looks super good. It will tweak the colors so that they look like it's filmed with the camera and then edited so that the colors looks good from HDR to low to LDR. Anyway, let's not go into detail. There is default tone mapping to ACES filmic tone mapping, and if you don't like the tone mapping, although it's a really good looking tone mapping, you can set flat to the canvas and check that. This is the default color. When I told you that the default one doesn't look that good and ACES looks much better, yeah, you get this. Obviously, we could have changed the colors, but the tone mapping is doing such a great job. All colors looks really a bit grayish, and I really like how they look. So if you prefer with the ACES, you can just remove the flat and it will work. By the way, if you put flat, the result will be no tone mapping, which is the same as linear tone mapping. But you can also provide your own tone mapping. To do that, the tone mapping are saved inside are available in the constants of Three.js. So first we need to import Three.js. So import all as 3 from 3. And in there, we will have access to the various tone mapping. Like if I do log Three.js C neon tone mapping, which is a different one than ACS. It's just a number, but this is the number we have to provide to the tone mapping to get the Kineon tone mapping. I hope it's Kineon. I'm not sure of that. If you prefer, you can just import the Kineon tone mapping. So we can do like this. Let's do it. Kineon tone mapping. Let me check if we use that version. No, we don't use that version. So keep the general one like this. And then to provide that tone mapping to the canvas, it's super easy. So I'm going to remove the flat. I'm going to go inside, so right now it's ACES, and in there I'm going to provide the tone mapping to 3.Kineon tone mapping, like that. And see, it's a bit different. I'm not a big fan of Kineon. Well, it depends on the color. The green and yellow never look really good with this one. I mean, it depends on what you want to get. Also, there is different mood, different tone mapping. You want to create something different, but you can do that. You can provide different tone mappings. Let's get back to the ACES because it looks much better. So you can just write ACES and let the autocomplete do the work. And we're almost done. Next topic is the output encoding. You remember this one? It's already set to sRGB encoding. Quick reminder of what the encoding is doing. When you encode color, so the color encoding is a way of encoding and decoding colors so that we store color information in a more optimized way, since we are limited by the amount of possible values per channel. All right, when we save, I don't know, an image or color or this kind of thing, we're limited by the values we can save so that the image is not too big. Where the encoding, we kind of tweak those values so that it's optimized for how we see them, and this prevents some precision issues, with gradients when you see the steps of the gradients, things like that. All right. For a better result, we better use the sRGB encoding. All right, it just works. You put the sRGB encoding when encoding and decoding, and it looks better. And by default, it's on. So it's the sRGB encoding that is used. If you want to change it for reasons, I think we do it a bit later, like with the portal scene, no spoiler. 3.linear encoding. We're going to need the linear encoding. I'm quite sure we need this one. We save, and as you can see, it looks different. This is not the tone mapping. This is really how things are encoded. It concerns textures, but also colors of the sphere, of the cube, and also what is output to the renderer. By the renderer, sorry. But I don't like this one. I prefer to use the sRGB encoding, which looks much better and doesn't mess with the color. Yeah, we can remove it, or we can just put sRGB encoding. Okay, let's go. Finally, maybe there's another one, the alpha. the background of the renderer is transparent by default, meaning that right now we are seeing some white, but it's actually the white of the page behind it. This means that we can go back to the style file, style.css file, and in here we can change the background. So light sky blue, yeah, why not? And now it's blue. And we didn't have to change on the renderer itself, we can just set it on the page. In a later lesson, we will cover a case where we want to change the transparent behavior, because yes, if you remember from the previous lessons, we can also set it directly on the WebGL renderer. We can still do that, but we are going to do it in other lessons, because this one is already long enough. Yeah, next one. So alpha was not the final one. We can set the pixel ratio. You remember the pixel ratio? Some screens have a pixel ratio of 1, meaning that 1 pixel that you see on screen is 1 pixel in your OS, in the image you are seeing. And if you use, like, let's say a Max, or if you use some phones, usually they have a pixel ratio higher, meaning that in 1 pixel you might end up with 4 pixels or even more, so that you can read very small text. It's more precise, so it's usually better unless it's too much, but that's the idea. React 3 Fiber handles the pixel ratio automatically. It's good practice to clump it in order to avoid performances issues. Remember from the previous lesson, some devices have a very, very high pixel ratio, like, I don't know, 3. A pixel ratio of 3 means that your pixel will be kind of cut by 2. So you have 3 pixels horizontally and 3 pixels vertically, and you get 9 pixels. And this means that the WebGL will have to render 9 times more pixels, and that's usually bad for performances, and your experience will start to the frame rate will go down, so it's quite bad. We need to clump it, even if the device has a high pixel ratio, where we clump it so that it doesn't go beyond 2. Usually you can change that, but usually it's a good idea to do that. And we can do that. So first of all, we can force 1 pixel ratio. So you can put dpr equal 1. So right now, everybody will have the same pixel ratio, which might look a bit blurry. So it's my case, but I think I have some zoom happening. I forgot, I zoomed for the React lesson. That was quite a big mistake. So right now it looks okay. And we can put more, like we are forcing more, which is a bit weird because right now my screen doesn't have a pixel ratio of 2. And you can also provide some limits, like clamp it. You can say, I want something between, so I provide an array between 1 and 2, like this. And if the pixel ratio is below 1, well, it will be clamped at 1. And if the pixel ratio is, I don't know, 3, 4, 5, which is crazy, it will stop at 2, which is good for performances. It will still look better than a pixel ratio of 1, but it will be good for performances because you won't have too many pixels to render. By the way, what we wrote just here, so 1, 2, so 1, 2, 2, is actually the default value set by React 3 Fiber. All right, React 3 Fiber is set by default like this, so we can remove this. We get the exact same value. So we can remove it, it's the same. Nice. About performances, yeah, just a few words. We're going to talk about performances in the lessons where tackling very specific topics. But in general, everything we learn about performances with Three.js still applies here. So you need to minimize draw course, you need to optimize the pixel ratio like we just did, you need to have very simple models, you need to avoid big textures, etc. This is still Three.js, so keep optimizing everything. React 3 Fiber and React also made possible interesting features to improve performances. We are going to see some of them, but I invite you to check that page. So check the links below as always. There is a page on the React 3 Fiber website that is talking about a few topics about performances, and some of them are very specific to React and React 3 Fiber and made possible by those two modules, those two dependencies. And just check that website, it's super interesting. Have a look, especially this part. This one is quite crazy if you understand, because it's quite complex too. Anyway, see by yourself. Going further, yes, maybe we can go further. We are going to dive deeper into React Free Fiber, but I provide you some resources if you are curious, if you want to pause the 3GS journey lessons right now and have a look at some things. First of all, with this website, so the React Free Fiber website, there is a getting started page where you will learn a few things. By the way, if you have the right resolution, yeah, it looks like that. So you can just follow those. We're going to see most of what you can find here, but if you're curious, you can have a look there. So Paul, the creator of React Free Fiber, also created a tutorial for React Free Fiber that you can find right here. So I put the tweet so that you can also follow Paul. It's a good tutorial. It's quite advanced. Maybe you should first follow the the 3GS journey lessons and then have a look at it. It's to create awards type website. So using React Free Fiber to create a cool website that can end up on awards with the minimal effort. Check it. It's super interesting. Next, if you have questions or need more resources, or you're just curious about what's happening in the React Free Fiber ecosystem, you can check the Point Menders Discord. Have a look. They are super active, very interesting. And finally, some people had fun recreating the 3GS journey lessons using React Free Fiber. So we're going to do that with a few lessons, but if you are curious, check that. Some of the lessons that we did during the first lessons of 3GS journey have been recreated in React Free Fiber. So if you're curious, have a look. Not all of them, but many of them. And it's by Hazem that you can also follow on Twitter. The link are right below as always. We are done with this lesson. I'll see you in the next lesson.